Welcome. In this video, we'll be tackling a classic algebra problem. Our main objective is to learn how to solve a system of equations when one is linear and the other is nonlinear. Specifically, we will find the values of x and y that satisfy both equations. X plus y equals 10 and x times y equals 20. By the end of this lesson, you will be able to take a system like this and use substitution to arrive at a familiar quadratic equation. Let's begin by writing down our two equations. We have x plus y equals 10, which we'll call equation 1, and x times y equals 20, which we'll call equation 2. Notice that the first equation is a simple linear relationship between x and y. The graph of this equation is a straight line. The second equation, however, is quadratic. The graph of this equation is a hyperbola. So we are looking for the points where this line and this hyperbola intersect. There could be 0, 1, or 2 such points, which means we might find no solutions, one solution or two solutions. The most straightforward method to solve this system is called substitution. The idea is to solve one of the equations for one variable and then substitute that expression into the other equation. Let's apply the substitution method. Our first step is to isolate one of the variables. We'll start with our linear equation, x plus y equals 10, because it's the easiest to work with. Here's equation 1 again, x plus y equals 10. We can solve for y by simply subtracting x from both sides of the equation. This gives us y equals 10 minus x. This new equation tells us what y is in terms of x. This is the expression we will substitute. The next step is to substitute this entire expression for y into our second equation, xy equals 20. So we take the expression 10 minus x and plug it in wherever we see y in the second equation. This transforms our equation into x times the quantity 10 minus x, which equals 20. Notice how we've eliminated the variable y, and now we have an equation with only x. We've now arrived at a single equation with one variable. X times 10 minus x equals 20. Our next task is to simplify this and solve for x. Let's start by distributing the x on the left side of the equation. This gives us 10x minus x squared equals 20. This is a quadratic equation, which we can solve using a few different methods. First, let's rearrange the terms to the standard form for a quadratic equation, which is x squared plus bx plus c equals 0. It's often easiest to work with a positive leading coefficient. So we'll move all the terms to the right side of the equation. Adding x squared and subtracting 10x from both sides gives us 0 equals x squared minus 10x plus 20. Now we need to solve this quadratic equation. Let's see if we can factor it. Can we find two numbers that multiply to positive 20 and add to negative 10? Think about the factors of 20. 1, 20, 2, 10, 4, 5. If we try to make them add to 10, we get 1 and 20, that's some bash 21. 2 and slash 10 xiang, and some 12 din, and 4 and 5, some 9. None of these pairs add up to 10. This means the quadratic equation cannot be factored easily, so we'll need to use the quadratic formula. Since our quadratic equation, x squared minus 10x plus 20 equals 0, is not easily factorable, we will use the quadratic formula to find the values of x. The formula states that x equals negative b, plus or minus the square root of b squared minus 4ac, all divided by 2a. First, we need to identify the coefficients a, b, and c from our equation. In x squared minus 10x plus 20 equals 0, a is 1, b is negative 10, and c is 20. Now, we substitute these values into the quadratic formula. This gives us x equals negative 10, plus or minus the square root of negative 10 squared, minus 4 times 1 times 20, all over 2 times 1. Let's simplify this expression step by step. Negative 10 is positive 10. Negative 10 squared is 100. 4 times 1 times 20 is 80. And 2 times 1 is 2. So we have x equals 10 plus or minus the square root of 100 minus 80 all over 2. This simplifies to x equals 10 plus or minus the square root of 20 all divided by 2. This is the exact value of our solutions for x. We found our two possible values for x, but we can simplify them further. Let's start by simplifying the square root of 20. We can rewrite the square root of 20 as the square root of 4 times 5. Since the square root of 4 is 2, this simplifies to 2 times the square root of 5. Now we can substitute this simplified radical back into our formula for x. This gives us x equals 10 plus or minus 2 times the square root of 5, all divided by 2. Notice that both terms in the numerator, 10 and 2 square root of 5, are divisible by 2. This means we can simplify the entire expression. We can factor out a 2 from the numerator and then cancel it with the 2 in the denominator. This leaves us with our 2 final solutions for x: 5 plus the square root of 5 and 5 minus the square root of 5. We have successfully found the 2 possible values for x. But the problem asks us to find x and y. Now we need to find the corresponding y values for each of these x values. To find the y values, we'll use the simplest equation we have relating x and y. Remember our rearranged first equation? Y equals 10 minus x. This is much easier to use than the original xy equals 20. Let's find the y value corresponding to our first x value. Case 1. When x is 5 plus the square root of 5. Substituting this into our equation for y gives y equals 10 minus the quantity 5 plus the square root of 5. Distributing the negative sign gives 10 minus 5 minus the square root of 5, which simplifies to y equals 5 minus the square root of 5. This gives us our first solution pair. Now let's find the y value for our second x value. Case 2. When x is 5 minus the square root of 5. Substituting this into our equation for y gives y equals 10 minus the quantity 5 minus the square root of 5. Distributing the negative sign gives 10 minus 5 plus the square root of 5, which simplifies to y equals 5 plus the square root of 5. This gives us our second solution pair. So we have found 2 distinct solutions that satisfy both of the original equations. Let's summarize our findings. We started with the system of equations x plus y equals 10 and xy equals 20. Using the method of substitution, we found 2 solutions. Solution 1. X is 5 plus the square root of 5 and y is 5 minus the square root of 5. Solution 2. X is 5 minus the square root of 5 and y is 5 plus the square root of 5. It's always a good idea to check your answers. Let's verify our first solution. For the first equation, x plus y, we have 5 plus square root of 5 plus 5 minus square root of 5. The square root terms cancel out, and 5 plus 5 is 10, which is correct. For the second equation, x times y, we have 5 plus square root of 5 times 5 minus square root of 5. This is a difference of squares pattern, which is a squared minus b squared. So we get 5 squared minus the square root of 5 squared. This is 25 minus 5, which equals 20. Our solution works for both equations. You can follow the exact same process to check the second solution, and you'll find it also satisfies both equations. Today, we successfully used the substitution method to transform a system of equations, one linear and one nonlinear, into a solvable quadratic equation. We used the quadratic formula and simplified our radicals to find 2 accurate solutions. You are now able to apply this method to solve similar systems of equations. Great job!